Before we talk about auction, let's consider a simple fixed price posting system, which is quite common in real life. So just for simplicity, just there is only one seller in the market. And we are going to consider a thicker market first. What do you mean by thicker market? A thicker market, there are lots of buyers in it. And then we are going to consider some thin market in which there are just one or just a couple of buyers are interacting in the market. Let's first consider a thick market. And suppose you have developed a new game app and you can produce that product at a zero marginal cost. And in order to determine the market price, you need to know the market demand. And the market demand is usually characterized by a demand curve. You know, this Econ 101 stuff. So there is a demand curve, and that's the price you are going to choose, and that's the quantity demanded market. And this is a demand curve, and typically this demand curve has a negative slope. That means if you increase the price, then demand will be decreases, right? That's why we call the law of demand. So we assume the derivative of the demand curve is negative. All right. And what's the optimal price? And you know, this profit or the revenue is the product of this price and the quantity, P times Q. And that means you are going to maximize this area. In order to maximize this profit, you have to get the derivative and set this derivative to be zero. Right? It's just using the chain rule, and you can get this derivative of the profit, and then you can get this optimal price that maximizes your profit or revenue. Now we are going to discuss thin market. As we discussed in earlier lecture, in many cases, resources are allocated in a thin market. There are few sellers and few buyers. There's the M&A and the job market and the treasury security market and housing market and so on. Those thin markets, the prices are not usually determined by demand curve, but those can be determined by some auction or negotiation or procurement, bargaining, and so on. So this is a simple example with the single buyer. Suppose there is only one buyer and there is only one seller we have, and the seller's value to the item is zero, and that is also known to the buyer. And the buyer's value to the item is X. Of course, that should be bigger than zero. And the seller offers a price, names a price P, and then the buyer either accepts or leave it. So what's the optimal price? Suppose both buyer and seller know this buyer's valuation, buyer's value X. If the seller knows buyer's exact value, then what's the optimal price for the seller? Just the seller sets the price equals to the buyer's value. So basically, if the seller knows the buyer's exact value, then seller can extract all the surplus. But importantly, now consider asymmetric information in which the buyer's valuation X is his own private information and the seller does not know the buyer's value. In that case, the seller cannot extract all the surplus from buyer, the optimal price that maximizes the seller's revenue depends on the seller's belief or assessment about the buyer's true value. So now we are going to focus on the asymmetric information. To the seller, the buyer's valuation X is a random variable, right? So here we need to distinguish this small x, that is realization of this random variable capital X. And buyer knows this small x, the realization of x, and this x is drawn from some distribution function f. So here again, the seller knows the distribution function f, but seller doesn't know the realization of small x. Okay, so you have to tell the difference between the small x and the capital X. Capital X is a random variable, and small x is a particular realization of that random variable. Okay, so what is the buyer's best response against a certain price? As before, the buyer should accept any price as long as his value X is greater than the price. Otherwise, just reject. And what's the seller's expected revenue? And seller's expected revenue is if the buyer accepted the offer, that happened, the buyer's valuation is bigger than the price, then the seller will get the price. The other case, get nothing. Trade will not happen here. No trade, and this is the trace. In the seller's perspective, seller does not know the realization of X, so this should be remain capital X, random variable, all right? And just take this probability. With that probability, trade will happen, and the seller will take this price. And this probability is 1 minus f of p. Okay? And given this, as before, the seller is going to choose this p star, the optimal price, to maximize this revenue, and again, get the derivative. And just again using the chain rule and set that to be 0, and that gives us the condition for optimal price. So here we have two extreme cases. One is the thicker market, and the other one is just one buyer. And actually, those are quite similar. And the seller's revenue is price times quantity demand. We have got this result, right? When there is one buyer, actually there is no demand curve, but the seller might have some chance of trade, probability of trade. That is sort of demand. So with this probability, trade will happen. So that is a version of a kind of demand, I can say. All right. And then it's a very similar situation here. And that is demand is just coming here. And that is the derivative of this part, right? Derivative of this part is minus f of p. So that is 1 minus fp and cancel out minus, right? So it has a similar form. Just replace the demand with the probability of trade. And what if there are multiple buyers? There are n buyers, and each buyer has a valuation to the item, which is a random variable in the seller's perspective, that is x1 and x2 all the way up to xn, and each buyer has each buyer's values is drawn from those distribution function. And then this revenue, the seller's expected revenue, is price times probability of a trade occur. When the trade happen, the maximum valuation among the all buyers is bigger than the market price, and then the trade will happen, right? Taking this as a random variable that follows this distribution function. And please recall the order statistics, and the maximum of those random variables is another random variable that follows the product of those distribution function. So we can have this optimal price for any market with n buyers. And this is the quiz, and again, please complete this quiz by yourself, and we can discuss in Teams channel.